Want to turn Python functions into AI-accessible tools with just 2 decorators and a single run command? We'll build a lightweight RPC server using FastMCP that exposes a simple greeting function as a callable tool. You'll see how the framework handles both local development with STDIO transport and network-ready HTTP deployment, while keeping your business logic completely separate from the communication layer. This pattern forms the foundation for AI tool integration, where models need to discover and invoke your Python functions. From FastMCP, import FastMCP. MCP equals FastMCP. Name equals my server. At MCP, tool. Def hello name, SDR. Return f hello, name. If name equals main. MCP, run. This demonstrates the RPC tool pattern for exposing Python functions as callable endpoints through a lightweight server. The @MCP tool decorator transforms ordinary functions into discoverable tools while maintaining clean separation between business logic and communication protocols. The distinctive aspect is how type hints automatically generate tool schemas, eliminating manual API definitions while preserving type safety. The pattern works by treating decorated functions as independent tool definitions within a FastMCP server container. The framework handles all transport concerns through explicit configuration in MCP. Run, where you choose between STDIO for local CLI use or HTTP for network access. This design allows the same tool functions to serve different clients simply by changing transport parameters, without modifying the core implementation. This approach solves the problem of RPC boilerplate while providing explicit control over deployment scenarios. You avoid writing root handlers or protocol adapters, yet maintain clear separation between local and networked operation modes. The pattern excels for AI tool integration, where functions need to be discoverable and callable by external systems, with the trade-off being framework dependency balanced by reduced infrastructure code. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for building lightweight RPC servers that expose Python functions as AI-callable tools. It handles the boilerplate of registering functions, validating inputs via type hints, and managing transport protocols, defaulting to STDIO for local CLI use, but configurable for HTTP to enable persistent multi-client access. The same tool definitions work across transports. You just specify the protocol when calling MCP, run. MCP equals FastMCP. Name equals my server. This instantiates the FastMCP server core, initializing a lightweight RPC server instance named my server. The name parameter serves as the server identifier for tool discovery and routing, particularly important when integrating with AI systems that need to locate and invoke specific tools. This follows FastMCP's decorator-driven pattern, where Python functions become remotely callable tools while maintaining clean separation from transport concerns. At MCP, tool. Def hello name, SDR. That MCP tool decorator exposes this Python function as a callable tool for AI models or remote clients. FastMCP uses the type hints to auto-generate the tool schema, defining the input-output contract without manual root configuration. This pattern is specifically designed for AI tool integration, where functions need to be discoverable and callable by external systems through either STDIO or HTTP transport. Return f hello, name. This f-string constructs the tool's response by embedding the validated name parameter from the function signature. FastMCP uses the type hint SDR and return annotation to auto-generate the tool schema, ensuring the AI caller provides a string input and receives a string output. The pattern keeps business logic clean while enabling seamless integration with AI systems that need discoverable, typed function interfaces. If name equals main. This is Python's standard entry point guard. It prevents MCP, run, from executing when the module is imported, ensuring the FastMCP server only starts when the script runs directly. The guard enables safe importing of tool definitions while maintaining explicit control over server initialization. MCP, run. This launches the FastMCP RPC server, exposing all @MCP tool-decorated functions as callable endpoints. By default, it uses STDIO transport for local CLI usage, but can switch to HTTP for persistent multi-client access via run host equals 0, 0, 0, 0, port equals 8000. The decorator approach eliminates manual root definitions while maintaining explicit control over transport selection, making it ideal for AI tool integration, where functions must be programmatically discoverable. FastMCP RPC Foundation. The MCP tool decorator bridges Python functions and AI clients by generating callable schemas, while MCP run launches a transport-specific server that exposes these tools as remote procedures. STDIO transport creates ephemeral per-session processes ideal for CLI integration, whereas HTTP requires explicit configuration to enable persistent network access. This single decorator pattern maintains identical tool definitions across different deployment scenarios, with transport choice being the only variable.
The function that never knows its caller answers all callers the same.